Okay, hello, Mr. Muller. This is gonna be an unlisted video because it's just for you, and I may do another video on this, like, to show it to everyone, but this is only for you, exclusive members only. So, I learned a new math. I don't know why I learned stuff, and I don't know what it's called, but it does involve complex numbers, which are very interesting. Sometimes this equation doesn't involve complex numbers, but it usually does, due to subtracting, and I'm going to show you how to do it. So we have this equation, which fully simplify when x is 5. So we have this, I may have added a few extra parentheses, but in this equation it doesn't matter. So this is more simplifying, not like getting an answer like what is equals, simplifying. So basically you can get the answer with one go instead of solving this mess, which I don't think you can even put this in a calculator. So we have CSC, which is another sign, and then we have sine -1 to use the sine rule. That's usually included in this equation. And then we have y over x, how to do our equation. This equation is nice because you can change it too. I haven't really changed it that much, but you can change x to the second power and e, basically everything, except the I and I'm not sure about the y for x, but it's a pretty changeable situation. So we start off with, if we simplify it, we get y over 5 because x is 5. And then we get the in, and we have to put the equation in brackets, sine -1. And then now we can simplify. We get the sine. If we remove the 1 over, the CSC switches to a sine, which means it basically, this whole equation basically goes on the top. Then it turns into a sine, which we'll later, pretty much next step is to use the sine rule. So this goes to, give me 1 second. So let me make sure I'm right. So I think I meant 4. So I'll be right back. I know this isn't very exclusive if I'm getting something wrong, but I mean, you're Mr. Molnar, you do accept mistakes. So I'll be right back, and I'll get a pen to switch it to 4. I just realized I really messed up with something. Okay, there we go, perfect. So I did the whole equation in 4, using the 4, since we use a lot of x in it, which is most of the equation. So, oh wait, I messed up bad. Well, not bad, but I don't know what. So that's 4. Give me 1 second, I want to reveal to you the whole equation. I'll make sure I'm right. My brain must have not been braining. Well, it must have been like half braining if I solved the equation, but it must have been like not braining at the same time. Okay, so everything seems like it goes with 4. Yeah, everything goes with 4. And the next equations, everything is right. Just so I could double check. So now we have this, and this 1 over 3 times 6, which would equal 2. Okay. This would equal 2. And then we have to do minus 16 because of the x to the second power at the end. And then we can go to the next step, which is where this way, let me try to explain the best I can. So we have to use a sine rule, which this is what I like calling it, but it's wherever you remove these together, sine minus 1 is sine. But there's some special rules with it. The main rule is that it has to be in between negative pi and pi, usually in the format radians, which is usually used in trigonometry. So we have negative pi to pi, which is the distance. You can't get any farther or any smaller, which usually is when some things get messed up or you have to use a rule. So this is called, you could call it the 2 pi rule. Okay, so that's basically saying that first with the equation, you do the basic, you multiply it, or add these to multiply to get about 350. Then it goes divide by, okay, let me try to remember this. So it goes divided by 2 pi, then take only the decimal, then multiply that by 2 pi, and then it has to be in the distance between negative pi and pi. So I'll show you how that works. So we do 350 about divided by 2 pi, which equals about 55.777110, which we only take the decimal. This is a stronger approximation too. You probably don't need this much decimals. And then you multiply by 2 pi again and see if it's still in the distance, which it is. It's 1.11371. If it wasn't, then you would have to subtract 2 pi or add 2 pi if it was too small or too big, and which is in the range. So now we have this equation. I'll have to add another parenthesis. Okay. So now we have IN 1.11371 minus 16, which should go to IN negative 14.88629, which you can multiply by 4. But the problem is, this is where the amazing complex numbers come. You can't have usually a logarithm. You can't have a logarithm as a negative. That wouldn't make any sense, and that would be more as undefined. Which is now we have to flip the page. And yes, that is not possible. It would be undefined. And this is just a log. And it's more saying, I'll show you. Well, it basically says how many, e to the power or what equals this. Which it's a little confusing, but this is, it'll look easy like this. Like, e to the power of what equals this equation, the top one. And it'll work in this. This is a negative. What? That doesn't make any sense. And also e is about 2.7. So now we're on the next thing. Now we have complex, which our rule is the log of the absolute value of the equation we want in the parentheses multiplied by x after using the log. So after, it's the second step, plus x, which would just be 4, plus 2k times x, which k usually needs integrals, which is also used in this. It's usually just an addition, but it has to be included imaginary, times pi I, which it usually wouldn't affect this. It would usually turn out to 4 pi I, or whatever this number would be. And then this would just do 2k times 4, which would be 8. So this is very easy. You can literally, give me 1 second. You could literally do this if you wanted to, which makes it very easy. But this is a little confusing, where we have to use the absolute value of the equation, which we know is always positive, which would do about 14.88, which if we use e to the power of what equals it, we get about 2.7, which is the same value as e, surprisingly. And then we could approximate it, but we don't have to. And then we could do, it would turn out to be, we're almost to the final answer. It would turn out to be about y is somewhat equal to 4 times 2.7, the top equation, which would equal more simplified 10.80471, which our final answer comes to be. With this, y is somewhat equal to 10.80471 plus the equation above, which we can pretty much leave like it, in parentheses 4 plus 8k times pi I, which would just go to 4 pi I plus 8k. And that's really our answer. We don't need to change anything else. This is the most simplified. And yeah, we have to multiply everything by 4, which is x. So it doesn't really want to give us the answer, which we probably could get the answer from this, even though it's in complex numbers. It's just they want us to simplify. Maybe they could be like in a question, simplify and solve, which we would have to solve this equation, which I do not want to solve. And I'm happy that it's not like that, which you could do that, but it's a lot harder to solve that. And that's basically it. I mean, it's not that bad as you think. It's not super hard either. It just contains a bunch of rules, which if you just get the hang of the rules, you literally can do any question. So that's it. Thank you for watching, Mr. Muller. And hopefully you saw this. If you did, thank you. Yeah. And thank you for being a great teacher, too. I really appreciate it. And hopefully you'll be able to watch some more of my videos and I'll be able to email you more, because I really like emailing you. Hopefully I'll get to see you in 8th grade too. Thank you for watching, and I hope that I'm able to make an exclusive members only video soon. You can watch that too.